Okay, so we're going to look at the direct proportion and then move on to indirect proportion. So direct proportion, it's similar to the proportion of how things work. If you look at the first question at the top here, we've got there are 5 times as many green pens as blue pens. Which proportion represents this relationship? And from Seneca we've listed down there that the proportion is the top one, and this is correct. So if you think we've got green pens to blue pens, so we've got 5 to 1. There's 5 times as many green pens as blue pens. Now, if you think if there's 10 green pens, how many blue pens would we be expecting? What's happened? We've times that by 2. So we would have to do the same thing to the other side, times it by 2, so there would be 2 green pens. 2 blue pens, sorry. If we then think, what about if there was 50? We've times it by 10. So again, we'd have to times the original one by 10. And we would expect there to be 10 blue pens to 50 green pens. Again, the ratio is the same, a 5 to 1 proportion. So, if we look at this direct proportion symbol here, we've got x is directly proportionate to y. That isn't an A, it is like a little fish. Half a fish if you like. Okay? So, what that means is x is directly proportionate to y. As x increases, y is going to increase by the same scale factor or the same proportion. Now if we rewrite that, you can see at the bottom, just at the bottom here, this means that there is some number which is defined as k, or a constant, such that x equals y multiplied by a scale factor. So what in effect we've done there is we've taken the centre equals k and replaced the proportionate sign with that. And that works in every single one. So if you wanted to have a go at the next one on the opposite side, this one here, you can feel free to stop the video, give it a go, and see if you've got it correct. Okay, so y is directly proportionate to x squared. So if I replace that sign with equals k, and I write the rest down, y equals k of x squared. And if you think, there's no sign in between these two individual terms, so there is actually a times sign there. So that's like k times x squared, k times y. This will be important as we come down. So, on this last part of the slide, what does this particular thing mean here? Y proportionate to x. You've just exactly said what it is. Y is proportional to x. It's not disproportional, so we know it can't be that one. Is it inversely proportional? Not in this case. We'll come to inversely proportional in a second. But y is proportionate to x. Moving on. In the first example, we've got 3 things we need to look at. The first thing will be to find when y is directly proportionate to x. So we need to write that as a proportionate symbol. So if you think y, directly proportional, remember, is our fish sign, and then we've got the x at the end. Y is directly proportional to x. That first bit is done. Secondly, we take the values that we're given. When x equals 30, y is going to equal 45. And we plug them directly into the equation. So, when x equals 30, y is going to equal 45. And I want to convert, remember what we did in the last slide, I want to convert this section here instead of being a directly proportionate sign, I'm going to convert it to equals k. And remember, really important, that there's a times sign between the k and the 30. Okay. Once I've substituted those values in, the key thing here is I need to find k, or the constant. I need to find what x is being multiplied by to give me the value of y. We know it's being multiplied by this value here to give me 45. So thinking about that, I'm just using rules of algebra. So I'm going to divide by 30, this side, which will cancel the times by 30, and I divide by 30 on this side also. 45 divided by 30 is going to give me 1.5, and that's my k value. Second part done. Finally, moving on to the third part, find y when x is 40. So I'm going to start with the same proportionality equation that we had. Y is directly proportionate to x, and I'm going to substitute in what I know, equals k times x. We know k is 1.5, and we're told x is 40. So I'm going to substitute those values in. X is 40, k is 1.5, times them together, and you get the value of y. 1.5 times 40 gives you 60, so y equals 60. Example 2. The voltage V across an electrical circuit is directly proportionate to the current I amps flowing through the circuit. So, do it in order as we would do in anything ratio. We've got volts is directly proportionate to I amps. V directly proportionate to I. First step, remember, find k. So, substitute in the values that we've got. Volts, 78. Amps, 1.2. And remember that my directly proportionate can be written as equals k. Exactly the same process. If I want to get rid of the 1.2, I have to do the opposite. Divide both sides by 1.2. Those two will cancel, just leaving me k. 78 divided by 1.2 is going to give me 65. So k equals 65. So I've expressed that in the terms of V to I. Find V when I equals 2 is the next thing I'm going to do. So, rewrite the equation out. So V is directly proportionate to I. So V equals k times I. And now substitute in the values that it gives me. Find V when I equals 2. I equals 2. Find V. And we also know that my k value is 65. So I'm going to substitute the k value into that point there. What about k? Substitute with 65. And then 65 times 2 gives me 130. So in that case, part B, volts equals 130. Finally, find I when V equals 162.5. I'm going to do that beside this one so we can see what's happening. Starting again with the formula. We're now told that volts is 162.5. We know the value of K is 65. And we want to find what I equals. (65) times I, or I times 65, can be written either way round. So to get rid of the 65 and leave the I on its own, I want to divide by 65 each side. So again, I'm just doing the reverse. 65 divided by 65 just leaves me my I. 162.5 divided by 65 leaves me 2.5. So, just to confirm, answer to A is going to be V equals K times I, or V equals Ki. For question B, my answer is V equals 130, and for answer C, my answer is I equals 2.5.